When a storm hits, you just gotta endure. It's one of those things where if I look back, would I have made any different decisions about how I've dedicated my time? No, because I think it's essential that one operate from a place of educated optimism, meaning that I want to operate from an optimistic and hopeful place about us moving forward with big projects, with grand ideas, whether that's saving the planet or making grand discoveries about the solar system and beyond.
Good morning, my friends, and welcome back to 5 a.m. Story Talk, a place to talk about stories in all their forms, the craft that goes into them, and the role that art plays in our lives. Today, I'm going to be joined by a planetary scientist and astrobiologist, one of the brilliant minds leading the search for life elsewhere in our solar system. My friend, Dr. Kevin Peter Hand, the director of the NASA Jet Propulsion Lab's Ocean Worlds Lab and author of the outstanding book, Alien Oceans: The Search for Life in the Depths of Space. Before he joins us, let's talk about how we're doing. Are you faring any better than me these days? It reads like the most insanely stupid apocalypse every time I make the mistake of visiting social media. I'm half Australian, and I live in Australia, thousands of miles away from this crazy. But the half of me that was born in and grew up in the United States constantly vacillates between finding a closet to, hide in and just screaming at my computer screen. I think I'm luckier than most in that I've always been comfortable immediately translating my angst about life and the world to the page as a way to, I don't know, not necessarily exorcise it, but at least try to give it some kind of shape, dimensions I can deal with. But what about you? Is 2025 affecting your life or works in progress at all? I'd also love to hear what you think about the 5 a.m. Story Talk podcast so far. This is episode 3, and I think I'm just beginning to get the hang of how to record and edit these things. I have to give a shout out to my brother-in-law actor and podcaster Ryan Devlin, who's been guiding me through this process. He's the host of the Struggle Climbing Show, which if you're a climber or just interested in the physical and mental dedication it takes to be a successful one, you should be listening to it. I'll link to it in the show notes. Anyway, the point is, thanks for overlooking a few of the growing pains I've gone through translating my 5 a.m. Story Talk newsletter to the podcasting format. I'm so excited about where this project is going to go, and to have you along with me on this journey. Okay, that's enough of that, but only because I'm so excited to introduce you to my guest this week. He's an old friend from LA and represents a major departure, or maybe let's call it an evolution for 5 a.m. Story Talk. I've decided to expand my chats to include, I don't know what to call them. Big thinkers, academic specialists, people who make me feel like a fucking idiot, all of the above. 5 a.m. Story Talk is an ongoing arts conversation, but that doesn't mean it is or even should be limited to artists and what they think about storytelling in our culture. What I want to do now is periodically mix things up by inviting non-artists to join me for broader discussions about their important work that intrigues me, but also how their areas of study have shaped the lens through which they see and understand art and what's happening in our world today. First up is Dr. Kevin Peter Hand, whom I've known for more than a decade now. His research focuses on the origin, evolution, and distribution of life in our solar system with an emphasis on Jupiter's moon, Europa. From 2011 to 2016, he served as Deputy Chief Scientist for Solar System Exploration at NASA's JPL. And from 2015 to 2023, he was Project Scientist for NASA's Europa Lander mission concept. These days, he's the director of the JPL's Ocean Worlds Lab, though he maintains several other roles, such as being the principal investigator of the Sherlock spectrometer on board the Mars Perseverance rover, which is tasked with seeking signs of habitability and past life on Mars. Kevin isn't just a lab rat, he's also a real-life adventurer, which we're going to talk about because I'm never jealous of him at all when I see pictures of him in the dry valleys of Antarctica, the North Pole, climbing the glaciers of Kilimanjaro, or at the bottom of the ocean. The bottom of the fucking ocean. He's made 9 dives at the last count, including one as the scientist on board James Cameron's 2012 dive to the bottom of the Mariana Trench, the deepest point on Earth. Kevin and I are going to cover a lot in our conversation. Obviously, we're going to talk about his work, But that work is being carried out in an incredibly turbulent time that challenges even the optimism of someone who operates at galactic timescales. But as dire as some of what we discuss is, Kevin offers consistently profound observations about why the search for life elsewhere in our galaxy continues to matter so much, the roles of science and art in understanding anything about existence here, and why humankind's future might not be as evolutionarily bleak as I often feel it is. After working on this podcast for a few months now, I really think this episode nails the tone I'm going for, which turns out to be me passing myself off as intellectual and philosophical, while my guests make me feel and sound stupid. Well done, Kevin. Well done. You've done wonders for my imposter syndrome, asshole. Don't forget, every episode of this podcast comes with a bonus episode in which my guests discuss a seminal piece of art from their lives. If you come back, you'll get 30 more minutes of Kevin and I digging into Steven Spielberg's Close Encounters of the Third Kind. Now, let's get on with it. Let me introduce you to my friend, Dr. Kevin Peter Hand.
It's great to see you, Kevin. It's been too long. How are you doing?
Great to see you too, Cole. It seems like another lifetime, another planet, another universe. I'm doing okay. It's strange times, but fortunate to be doing what I'm doing and living the life that I'm living and trying to keep perspective on that.
Before we get into who you are, what you think, where you're from, all that, I want to ask you when the last time the universe blew your mind was. Something that surprised you, something you saw, something you learned. It doesn't matter. Just blow my mind too.
How about 3 hours ago? So one of the exciting things about what I do as a scientist, at this time I'm principal investigator of one of the instruments on the Mars Perseverance rover, a spectrometer called Sherlock, which also has a great camera along with it. And so being a part of the Perseverance mission on Mars means that when I wake up in the morning, I can log in and see the latest images and data that's downloaded. And just a few hours ago, our team was having our weekly team meeting to figure out everything we're doing this week. And in the group chat for the mission, somebody had posted the latest images. And these images, they're already on the internet, available to anybody. If you just go to, I think, like mars.nasa.gov or something like that. There's an image of this rock that had all of these spherical features on it. It was sort of if you imagine a bunch of beads that you would use, say, for a wrist bracelet or a necklace, imagine a bunch of those beads sort of compressed together to make a rock about the size of that, maybe a cantaloupe or so. It's just a jaw-dropping image taken from the rover looking at this rock on Mars. And we don't really know what it is. We think it might be these glass spherules made when an impactor hits a rocky surface like Mars and just ejects glass that then crystallizes or solidifies into these round spheres. So yeah, that in answer to your question, about 3 hours ago when I saw this picture of this bizarre rock on Mars that had a bunch of us scratching our head, and we think that rock is connected to some sort of impact on Mars, perhaps billions of years ago, perhaps millions of years ago. We don't know, but sure was fun looking at it.
I think what's interesting about that observation is just the fact that I suspect you're not going to be able to answer that question. And it's just one of 10,000 questions you probably encounter every year that isn't going to have an immediately obvious answer about Mars's nature. Is that accurate?
Well, so immediate is the operative word there. Nothing that I do is immediate. That's just this one example. The big picture for what we're doing is eventually getting these samples back to Earth. And that's been a many, many decades long endeavor. All of the missions in which I've been involved with have taken decades of planning, decades of typically not decades of building, but of order, a handful of years or so to build and then get to the launch pad and stuff. But yeah, so with this particular rock, we may direct the rover to go over and take a closer look, and we've got instruments on board and we can examine it more closely. And then we do have a collection of rock cores that are in the underbelly of the rover right now. We also dropped off a set of cores on the surface of Mars as kind of a backup task, but eventually we'll return some of these rock samples to Earth to look for signs of past life on Mars, to allow us to do very detailed age dating of the rocks to better understand the formation history and evolution of Mars and its place in the solar system and relationship to Earth. So nothing immediate, but, I operate on astronomical and geologic timescales. So when you kind of scale out to those timescales, immediate has a different meaning.
Well, it's interesting because we'll also be talking about Close Encounters of the Third Kind later, which is a film that blurs the line between faith and science. And listening to you, so much of what you do does require some degree of faith. Patience, I guess, is another way to describe it, but faith that it will pay off someday, that there is a promised land at some point in the future.
Yeah, and I've worked on projects that have been mothballed or canceled due to budgetary or administrative, or the winds change on timescales much shorter than the lifetime of any of these missions. And sometimes the winds are all blowing in the right direction, and sometimes those winds change direction rapidly. And all you can do is do your best while the wind has got your sail. And then when a storm hits, you just gotta endure. It's one of those things where if I look back, would I have made any different decisions about how I've dedicated my time? No, because I think it's essential that one operate from a place of educated optimism, meaning that I want to operate from an optimistic and hopeful place about us moving forward with big projects, with grand ideas, whether that's saving the planet or making grand discoveries about the solar system and beyond. You want to operate from a place of hope without being naive. And so kind of educated optimism, I think, is where I approach things, and with various ups and downs that I've had to face throughout my career. Yeah, in retrospect, if I had known that something was going to be mothballed after nearly 20 years of dedication to it, then I might have spent my time differently. But at the time, even if there's a small chance that something great happens, it's worth that sacrifice, especially on the human timescale. These missions, these big science endeavors, they're the cathedrals of our day. And so they're generational.
Well, I think that's what I was probably thinking about when I asked that question. Cathedrals, you said generational. These are investments in the future, the same as when you plant a tree. So much of your work doesn't pay off in your lifetime. It is an investment in generations to come, and the species, our civilizations tomorrow, which hopefully there is one.
So one of the key factors, you're familiar with the Drake equation, right?
Yes.
Yeah. The last factor in the Drake equation, that equation that allows us to kind of estimate how many intelligent communicating technologically advanced civilizations might be out there in the galaxy. That last factor is L, the lifetime of that civilization. And, who knows, maybe here on Earth, that capital L, that lifetime of our civilization is not going to be very long, but hopefully with science and art and all these things, we can kind of stay on a course that allows us to live longer, to behave in a more altruistic way that gives humanity a a chance at lasting for thousands, if not millions to billions of years.
I've often joked that we haven't met another species, another civilization from somewhere out in the stars, not because they've all destroyed themselves, but perhaps we're the problem. It's just we're the neighbor with the grass growing up too high, and the beat up car in the driveway, and
You're giving us way too much credit. You're giving humanity way too much credit. We're not even at that level. Here on planet Earth, we are an anthill in a galactic national park. We're 8.5 kiloparsecs out from the center of the galaxy. Parsecs 3.26 light years. So we're quite a ways out from the center of the galaxy. If the center of the galaxy is inhabited and kind of downtown Manhattan, we're way up in far northern Canada, and we are in potentially what the galactic civilization is partitioned out as a galactic national park. And we don't even rise to like the level of a neighbor who other species want to avoid. We're an anthropological curiosity.
But now I'm imagining that we're the national park that nobody really wants to go to. We're the number 348 on the list of national parks that nobody ever passes through.
This sort of attractive thing for us. We first started discovering exoplanets back in the 90s, and now we know of many exoplanets, and it's sort of more common for a star to have a planet than not to, and we're still trying to figure out the sort of demographics of size and types of planets around stars. But at least right now, our solar system kind of stands out with regard to the number of planets that our sun has. And so I can imagine that like Arches National Park, beautiful park, and you want to go and see the arches. Maybe at a galactic national park level, we're kind of that solar system where it's like, oh, wow, look, they've got this gas giant. They got some nice rocky planets and a couple of ice giants. It's a really pretty solar system. Oh, and by the way, there's some biology on one of them, and maybe on some of the moons of the outer solar system of that massive gas giant. So yeah, in my kind of optimistic vision for long-lived civilizations, I like to think about how we might be viewed by some grand civilization that's billions of years older than we are.
Well, so my guests are typically artists of some kind, which means most of my listeners have some idea about the work that they've done. You're a scientist. It's a bit uncharted territory for what I do. So maybe before we continue the conversation, you should talk a little bit about what you do. For example, you're an astrobiologist and planetary scientist. A lot of people might not know what that means.
Yeah, we kind of dove right in there on galactic civilizations. You sound like we come back a step. Yeah, so I'm a planetary scientist and astrobiologist, studied physics and astronomy with some mechanical engineering and robotics and chemistry and geology and biology smattered in there. And my research focuses on the search for life in our solar system. And I specifically focus on these alien oceans, these worlds of the outer solar system, these moons of Jupiter and Saturn and possibly even Uranus and Neptune that are covered in ice. These moons are covered in ice, and beneath their icy shells, we have good reason to predict that vast, potentially global, salty liquid water oceans exist. These are oceans that exist today. These are oceans of H2O, water that you know and love and depend on. And if we've learned anything about life on Earth, it's that where you find the liquid water, you almost always find life. As a result, these ice-covered ocean worlds of the outer solar system are prime places, in my opinion, and many of my colleagues' opinions. These are prime places to search for life beyond Earth. And In particular, these are places to search for extant life, life that is alive today. And that's an interesting contrast. I mentioned my work on Mars, and I love Mars, and I think Mars is an incredibly important place to study with respect to past habitability and the prospect of past life on Mars. But on Mars, we're looking at rocks that are billions of years old with the question of and excitement about searching those ancient rocks for past life on Mars. Whereas on a world like Jupiter's moon Europa, if we found organic compounds or evidence of something intriguing on the surface of Europa, that could well be an indication of life actually alive today on Europa. Now, that said, there could be life alive in the subsurface of Mars, but then, imagine that life on Mars is based on DNA. Mars and the Earth are very close together, and they've traded material through the eons. And so if we found DNA-based life on Mars, that may have some connection or may have been seeded by life on Earth or vice versa. Whereas if we go out to Europa and find DNA-based life, that to me would indicate some biochemical convergence towards the DNA biochemistry. So that's kind of a quick synopsis. My overarching goal is to search for life beyond Earth, to see whether or not a second origin of life has occurred in our own backyard, our own solar system. And as amazing as it would be to find life beyond Earth, I think it's important to emphasize that even if we don't find life, that answer is equally profound. And if we search our solar system, if we search all these exoplanets and find not a hint of life beyond Earth, that means that biology on Earth is some sort of biological singularity. That something occurred here that we have yet to understand, yet to explain.
That sounds more like an existential answer about our potential uniqueness. But if you found life, why does that matter to humanity today? What is the relevance, I guess? If people are asking, why are we spending this money on this massive efforts? Why not spend it on just moving to the moon or Mars?
Yeah, so that's a great question, a really important question with lots of different threads there. Why not spend money on trying to cure cancer or solve climate change or any number of different things? And so let me kind of unpack that in a few different ways. First, the word that you used there was massive. It's not a massive effort. Just for perspective, NASA's annual budget is in the range of $25 billion per year. That covers everything from Earth science to astrophysics and heliophysics and planetary science and aviation innovations and human exploration, the development of new satellites. So 25 billion versus typically people think that NASA's budget is comparable to the military budget, which, DOD plus Pentagon plus several other roll-ups in there, you're looking at $1 to $1.2 trillion. So 25 billion versus 1 to 1.2 trillion. And just as another sort of benchmark that I like to use, I don't have a good citation for this number, but off the top of my head, but it's a figure of merit that I remember reading a number of years ago, where in this day and age, to build a mile of highway in a multi-lane urban setting is about $1 billion. All right. And that's like end-to-end clear rebuild. That's not just a repave and revamp. So in any case, that gives you kind of some scaling for massive. DOD, Pentagon, et cetera, that's a massive budget. When it comes to, say, climate change research, and let's spend money on that instead, 100%. I think we as scientists, I do some climate change research, but to be clear, the verdict is in. We know the story of our changing planet. We can continue to do work on it, and I will continue to do work on it. But what's needed from an action standpoint is not another science manuscript talking about how hot the planet is getting. What's needed is policy, action, and change. That's the difference that needs to be made. Cancer research actually quite well funded. The NIH is typically funded at about $35 billion per year or so, about 10 billion more than NASA. And then there's obviously tons of foundations and private efforts. And by some metrics, the research can't quite keep up with the funding because there are a lot of threads to explore. And it's incredibly exciting seeing what's happening these days with mRNA research and possible cures for cancer. Okay, so then let me finish with your main question, like the so what. Okay, so what if we do this, right? Because that was at the heart of your question initially, right?
Yes.
And so if we were to wake up tomorrow and see a little alien waving hi to a Mars rover, or get a signal from the search for extraterrestrial intelligence effort, that's not going to change the way you make your coffee in the morning, or shorten your commute, or lower your taxes, or do anything that has immediate repercussions that make you happier. But what it will do is the following, and I like to harken back to Galileo. Think about Galileo turning the telescope to the night sky. The telescope was initially a military instrument, and anybody who had a telescope was looking for ships on the horizon and trying to provide some advance warning of ships coming in. And then Galileo turned the telescope to the moon and to Venus, and eventually to Jupiter, where he discovered the moons of Jupiter. And night after night, he charted the revolution of those moons around Jupiter. And with that, he put the final nail in the coffin of Aristotelian cosmology, the idea that the Earth is at the center of the universe and everything revolves around the Earth. And he opened the doorway to the Copernican revolution, the idea, of course, that the Earth orbits the sun, and the planets orbit the sun, and the sun is a star, and the stars that we see could be home to planets of their own. And in the decades after Galileo, with folks like Newton and others advancing physics, we've come to appreciate that worlds and wonders beyond Earth, the laws of physics also apply on those worlds. And then with the advent of spectroscopy and using spectrometers on our telescopes, we could study the composition of stars and planets, and we would come to appreciate that the principles of chemistry work beyond Earth. And then with the advent of the space age and sending our robotic spacecraft and astronauts to the moon and Mercury and various places in our solar system, we would come to understand that the principles of geology work beyond Earth. But when it comes to that fourth fundamental science, okay, physics, chemistry, geology, and biology, when it comes to the science of biology, when it comes to the phenomenon of life, the stuff of us, we have yet to make that leap. We don't actually know whether or not biology works beyond Earth, whether it works independent of life on Earth, whether or not biology is a universal phenomenon, or if the life on Earth that we see here is some sort of biological singularity. And that's a really profound change in our understanding of the universe in which we live. If there is life beyond Earth, then we live in a biological universe. If we don't find life beyond Earth, then life here on Earth is some sort of singularity, the existence for which we don't yet understand. So there's a revolution that we are on the footsteps of. It's a revolution in biology. Physics went through a revolution. Chemistry and geology had their own forms of revolution. But we are at the doorstep of a revolution in biology. And the way to advance that revolution is to search for and figure out whether or not we are alone.
It was a great answer.
Sorry, I went on there for a bit. I kind of had to bring you along with the everything that goes into it.
you don't have to sell me. My first kid's named Darwin, and my wife vetoed my choice for my second kid, but I wanted to name him Copernicus. And so there we go. I hope we find it, and sooner than later. So I've also always been envious of your, I don't know, street cred as a real life adventurer. You're not like every other scientist I've known. You're out there doing really exciting things, dangerous things. You're North Pole, Mount Kilimanjaro. I don't know how many dives you've been on now to the bottom of the ocean, but the Mariana Trench with James Cameron. It's insane. So I'm curious how, because everything else you're discussing is exploration looking out, and it's fairly safe. I assume there are arguments in the labs and within your team. But it's a safe experience, and that other is more tangible. It's you experiencing it yourself. I'm curious how those experiences have changed you, just as a person, but also as a scientist.
Yeah. Thank you for those kind words. I grew up in a small town in Vermont, and my childhood was an amazing childhood with a supportive community and amazing parents and siblings and friends. And to some extent, my childhood is well encapsulated by the Calvin and Hobbes cartoon of just finding a universe in a puddle. And so with that came not just an interest in exploring and following my curiosity and building model rockets and stuff, but also just kind of getting out in the woods and climbing to the top of a mountain to see what was beyond that horizon. And so at an early age, my friends and I, we just went out in the morning and came back most of the time before it got too dark. And so I think just I kind of grew up innately wanting to explore and see new things. So I got into a lot of caves in Vermont, did a lot of climbing and mountaineering and skiing and stuff. So as a scientist, I've tried to layer some of that in, and that has led to some pretty incredible adventures, as you mentioned, at the bottom of the ocean and Antarctica and the Arctic, and some high mountains and some caves and things. Yeah, that has helped many different facets of my research, but one area that's kind of particularly tangible. There's a saying in geology that the best geologist is the one who has seen the most rocks, and that's it's got a real truth to it, because geology. I did physics, and truth be told, when I was an undergrad, I was like, geology. They're just looking at these rocks, and they're not very quantitative. I wanted equations. I wanted math. I wanted to be able to write things down that could predict what was going to happen. And sciences like geology and to some extent biology don't have that luxury of an adhesion to math that is strictly predictive. And so experience counts for a lot. People getting out there and seeing different bed forms and formations that you have to work with up close to understand the history of our planet. And I think in parallel to that kind of adage of the best geologist is the one that's seen the most rocks. When it comes to the understanding of life on Earth and the search for life beyond Earth, I like to think that perhaps, it helps as an astrobiologist to see life in many different aspects of its extreme and not so extreme form. So I've seen chemolithoautotrophic microbial communities up close, over 3.5 kilometers down in the Atlantic, and cryptoendoliths in the transantarctic mountains, and psychrophiles up in the sea ice of the far north. And all of those help kind of inform my ability to assess whether or not worlds like Europa or Enceladus or Titan could be habitable or even inhabited.
Does it have an impact on you as a human being, though, to see life in such extraordinary places, perspective-wise? I'm not really sure what I'm asking, probably leaning more toward the spiritual side of things. I think you're an atheist like me. But whatever you are, just those experiences seem life-changing for the average person, and you've done a lot of them as a way to contextualize the universe.
It has absolutely no effect on me. I'm dead inside, Cole. Yeah, 100%. Right? Profoundly invigorating and inspiring, and I'm a smart person, but I know many people much smarter than me and stuff, and I don't really have any incredibly good talent, I would say, other than somehow, perhaps, given my youth in Vermont and being sent up onto the mountain in incredibly cold temperatures, my one superpower may be that I get invigorated by really, really cold environments. And so being out there, 87 degrees north, standing on 5 feet of sea ice with miles of ocean beneath that ice, and just, it's dark out because it's the polar winter, and you're collecting ice cores, and you've got a tingle on the back of your neck because there might be a polar bear out, and so, but yeah, it's incredibly inspirational. I am an atheist with, a nod towards agnosticism, just in case there's, something completely safe. Right. I mean, that's part of why I'm interested in searching for extraterrestrial intelligence. Maybe they got the cheat code for religion and philosophy. I'd love to see what their great books are. But yeah, to the extent that I have any religion, it is through that connection with nature and the universe. Filling that cup of wonder and awe is kind of part of what I seek to do.
This might be a good place to pivot to the fact that this is primarily an arts and culture podcast. And so one of the things I wanted to ask is, do you think science alone is adequate to explain our place in the universe? Or do you think art and artists have a vital role in this regard too? Are they necessary to communicate things that perhaps science can't for most people? You don't have to say it is just because I'm an artist.
Let me do a very sciencey thing here and question the premise of your question. So you said adequate to explain our place in the universe. What do you mean by explain?
I think we've obviously relied on God for years. Some people look for understanding, and then science happens and quantum physics happens. Is there a limit to the ability of science to help 99.5% of people on the planet articulate their own place in the universe, where if we're not going to rely on God anymore, if that's a waste of time, is there a place for arts, the poetry of existence in some way to explain those bigger ideas?
So let me answer the latter by simply saying yes, and we can unpack that more. But let me return to the initial part of the question and the and sort of what you were saying there. Just making an important distinction. I think the premise is kind of flawed in that science is not actually good at explaining the why of the universe. Okay. Science is good at perhaps revealing the what and the how. Okay. I drop a pen. Okay. It falls thousands of years ago. We didn't know why. We just know that we didn't know what or how was causing it to fall. Fast forward to now, and we have a theory of gravity, and we know that mass in the universe will draw things to it, and we've got lots of equations to make predictions and to explain what we observe. But if you were to ask me why gravity, or why quantum mechanics, or why the universe is made of strings, why is the universe made of strings? I mean, I could potentially give you an answer of like, well, if it wasn't for gravity, then this bad thing would happen, and life wouldn't be possible, and we could get very anthropic with our answers. But the truth is that even with a complete explanation, a unified theory of every aspect of the fundamental forces, scientists would still not be able to answer why. We would be able to provide the why of the equations and the formalism, but what's behind that all, that's not what science is good at or particularly designed to answer. Science is a process for developing and testing hypotheses, et cetera. When it comes to our place in the universe, well, let me throw this back at you. Do you think it's useful to test hypotheses associated with our place in the universe? Because that's ultimately what science is useful for, is developing a hypothesis and then iterating on that. So give me an hypothesis for our place in the universe.
I don't know if I care. That might be a middle-aged thing, but I've just reached this point where I think, I don't know, if we're in a simulation, that's fine. I don't know. I'd like to understand that, but the experience of it is what I spend 90% of my life on. How do I explain the experience of what we're doing, this conversation, the moments you were just describing that you've had around the world? There are facts, but I find facts are a very poor way to achieve understanding for the average person. And I think that's probably where my question comes from. And with regard to art, most of us will never grasp even 20% of what you do about the universe. It's not relevant to most people's daily consciousness. And yet it is. I don't know if I'm explaining. They might not be able to articulate it like you do, but something has to explain it to them. And I think that's where art comes in. I've rambled a bit through that. Did any of that make sense?
Yeah, totally. And let me pull a thread in there, which is that I think where science has been so important is in the emergence and stability of societies and civilization. Now, obviously, we've got various rough patches, no doubt, and I won't dive into the modern epic, but in the long arc of civilization, science allows us to move away from myths and fictions that get in the way of medicine and our ability to heal each other and to innovate in ways that improve the quality of life over the long arc. So, critical thinking, science are essential to civilization. When it comes to meaning, for me, and when I was in high school, you find this interesting. I was actually voted most artistic. And I mean, we didn't have much in the way of science in my high school. It was a pretty basic high school. But I made a specific decision about going the science path versus going the art path. And some of that boiled down to the pleasure of finding things out, to borrow a phrase from Richard Feynman. I'm one of those people that when I do a math problem or even a Sudoku or something like that, I get a little endorphin release of solving a puzzle or doing fundamental research and building things and conducting experiments. I also enter that deep kind of meditative Zen state and enjoyment when I am painting or drawing or working with wood. And so the connective thread here, for me at least, is that art and science converge in the realm of creativity. Nothing is more important for a scientist than creativity. And some people might say, well, that can't be true. But when I talk with students, I say, as a scientist, you're only as good as your most recent original idea and your original thought that builds upon the foundation of the science that's been published before. Creativity without any reins. Creativity without discipline is useless. We're all creative beyond our ability to put it into motion. We have many more ideas than time. But as a scientist, the challenge is to learn the discipline, whether that's math or chemistry or something like that, to then constrain your creativity to be useful in the scientific process. As an artist, I got to imagine you got a similar thing where it's like knowing you a bit, you're incredibly creative. But if you did not have the discipline of knowing how to put pen to paper, to put fingers to keyboard, your creativity would be useless. And so, I find meaning in creativity and new ideas coming somehow into my brain, be that scientific or artistic.
It's a fascinating answer. I appreciate it. You went in a direction I didn't anticipate. So part of what you were just discussing connects to another question I wanted to ask. I think of you as a science educator as well as a communicator. You're incredibly articulate at being able to bridge these gaps, just as you did between art, between creativity / art and the sciences. Art, I'm sure, inspires many people to become scientists as well. I experienced that with some dinners that you and I had, where scientists went down that path because of a film that changed their lives. But very often that means poor science. And so how do you feel about films, TV using shitty science, but still inspiring people to pursue careers in STEM and whatnot? Is it just a price that the science community in the world has to pay to create new scientists?
Yeah, it's as you know, I've consulted on a wide variety of things, and whenever I start working with a producer, a director, a showrunner, a writer's room, etc., I would start out with the question of, what do you want science to do in your story? Because sometimes the allegiance to getting the science right can really compromise the story. You can have great science, but if you haven't developed your characters, then nobody's going to enjoy the story. Because, as you know better than me, obviously, when you're telling a story, you got to get characters that folks want to buy into. Meanwhile, if you portray the science so poorly, it's going to be a distraction. And people are going to be so distracted by the absurdity and sort of the offense to their rational thinking that they're not going to pay attention to the characters. So there's a real sweet spot there where the science is written and portrayed in a way that kind of subtly engages the viewer without them necessarily knowing it and without beating them over the head with it. And the science motivates the story and helps the development of the characters. And I think there's some great examples of that. 2001 Space Odyssey is obviously the all-time classic. But, even with various detective TV shows or the serials with cops and detectives trying to solve a crime case, I feel like those shows have gotten more sophisticated over the years, talking about DNA evidence and various techniques. And I think a lot of those shows have shown a nice way in which science helps make the story more interesting and also imparts on the characters, be they lab technicians or cops or detectives, kind of another layer of their development. So yeah, I think there's definitely room for improvement, but I don't like to see people go so far overboard that it compromises the storytelling.
There's a saying I have about storytelling that facts are great, but they often get in the way of the truth, which is that the why maybe you were referring to, and maybe what I was getting at with that earlier question about science and artists, that sometimes to tell a story that achieves a greater truth, the facts do have to be bent a little here or there, and sometimes the science is horribly wrong, but the end result is somehow Nichelle Nichols creates a whole new generation of women in the sciences as the result.
Yeah, 100%. And so, there's definitely the component of kind of fun, popcorny movies that inspire kids at a young age, and that's incredibly important. And I definitely benefited from that. Well, we're going to come back in a moment and talk about Close Encounters of the Third Kind, but I want to ask one more question, which perhaps is I'm guessing more of a downbeat question. Maybe it should have come in earlier, but how do you feel about the state of science education at the moment, the future of space exploration in the US and the world in general? It feels like a fairly grim time. Are you optimistic? I have to be optimistic in part because of what I was mentioning earlier, educated optimism, informed optimism, but also it's important to appreciate that given what I work on, I think on timescales that are typically longer than most people. So how do I feel about the next year, the next 2 years, the next 4 years, the next 10 years? Those are oscillations, if you will, that I have a hard time tracking these days, as everyone does. And so my optimism is cloudy at best in that sort of short-term timescale. But on the longer term timescale, I do think, and this is a more complicated topic than maybe we really want to dive into, and I write a bit about this in my book, Alien Oceans. But I do think Darwinian evolution at some level selects for altruism. And over long timescales, we see that with the emergence of groups and societies and civilization, and it certainly can all come crashing down. But I guess I put a lot of faith in the emergence of altruistic behaviors at different scales. And let me just give you an example of coming back to our earlier discussion about exploring our world. If you go down to the bottom of the ocean, as I've been fortunate enough to do in a Russian submersible, and to see these hydrothermal vents, these hot springs at the bottom of the ocean that are spewing out gases and minerals that microbes love to chew on. Down at depth, you cannot do photosynthesis. And so the microbes, the base of the food chain, are doing chemoautotrophy. They're eating some of the gases and rocks that come out of the hydrothermal vents. And the ecosystems down there, which have zooarcid fish and tube worms and crabs and mussels and all sorts of larger organisms and shrimp, those organisms have developed symbioses with various microbes. And those microbes work to detoxify some of the waters. The Riftia tube worms have got these microbes that help clean out the sulfur in the water, and the shrimp wear these little backpacks of microbes that help protect them from toxins in the water. And so down there, you see that Darwinian evolution is not just about survival of the fittest and predator and prey. You see it's also about mergers and acquisitions. It's about developing partnerships. It's about symbioses. And that selection effect that you can see directly around hydrothermal vents has gone over all parts of our tree of life. Our own, mitochondria and ribosomes, the organelles within our cells, once upon a time were independent microbes that then, through a process of mergers and acquisitions, led to the complex cells that we now depend on. And so that's altruism. That's symbiosis. That is a form of kind of Darwinian altruism where it's like we can get more done together through that mergers and acquisitions and partnership process. And here we are now with a civilization of seven. I forget what our latest population number is, but let's call it 7 billion. We are a global civilization of 7 billion people, and we are teetering on the precipice of stability and instability. But we have gotten here through altruism and symbioses manifest in our various forms of government, our various partnerships, our various collective agreements. And yeah, on the short term timescale, we're in a turbulent period. On a longer term timescale, I'm optimistic we'll make it through.
I'm glad I asked that as the final question because it didn't go nearly as dark as it would have if somebody asked me, how are you doing right now?
I can get dark when we grow up. I can go there. Don't have my ability to go dark in the shorter time scale. Yeah.
Well, thank you so far. We're going to be back, as I said, to talk about Close Encounters of the Third Kind, but I've really loved the conversation so far.
As for you listening at home, thank you so much for being with me here today. Really, it means the world to me hearing how much people are enjoying these conversations. But don't run just yet, because there's more. Kevin returns for a bonus episode, exclusive to my Rockstar paid subscribers. If it's not available on the player you're using, don't worry. You can find a link to it in the show notes. In this bonus episode, he discusses a seminal piece of art from his life, Steven Spielberg's Close Encounters of the Third Kind. The film played a formative role in his life, more so than a more obvious film like 2001: A Space Odyssey, which actually relates to Europa and his life's work. We're going to try to unpack why together. If you're not yet a paid subscriber to 5 a.m. Story Talk, you can become one at all the major podcast players for a price I've tried to keep low. But if you head to Substack right now, for a couple more dollars a month, or $60 a year, you'll get access to all the same podcast episodes early, sometimes even weeks early, as well as access to hundreds of arts articles, most of them focused on screenwriting and writing, and the opportunity to join me for monthly Ask Me Anything About the Arts chats to hopefully help you with whatever you're struggling with as a creator. You'll also directly help me make the 5 a.m. Story Talk podcast possible. Upcoming guests of this podcast include John August, the screenwriter of Big Fish and co-host of Script Notes, Derek Kolstad, the creator of the John Wick franchise and screenwriter behind its first 3 films, and Liz Hanna, the screenwriter of The Post and, most recently, creator of the TV series The Girl from Plainville. Next week, I'll be joined by Veronica Sullivan, the director of the Melbourne Writers' Festival, to talk about the event, curation as a form of creation, and how literary fests are rapidly evolving in the 21st century, including to recognize writers publishing places like Substack. Thanks for supporting my work here. See you soon.